Assalamualaikum warahmatullahi wabarakatuh, and good day to all the panelists that will be watching and evaluate my presentation. My name is Nik Muhammad Arif Fahmi Bin Mohd Rodzi. My supervisor is Professor Madya Dr. Juri bin Saidon, and I am from session March until July 2021. Would like to present my FYP proposal entitled Ultrasonic Assisted Milling of Glass Development of Cutting Force Through Mechanistic Mathematical Model. For the project summary or overview, this project will be focusing on the mechanistic mathematical modeling for axial cutting force. It is based on material removal process mechanism, which is ductile and brittle models. It is also can be used to predict the cutting force without conducting an actual experiments. The long-term objectives and specific target of this final year project is to develop and investigate the mechanism of material removal for ultrasonic assisted milling of glass for ductile and brittle models by using mechanistic mathematical modeling approach. This project aims to develop mathematical model in order to predict and to model the axial cutting force in terms of process parameters. For the introduction or the background study of this project, it is the combination of mechanical engineering and mathematics field. We want to identify the influence of cutting force that affects the machine surface quality. In the current models of this project, the effects of the cutting tool's rotation and ultrasonic vibration motion were taken into consideration. The material removal for ductile mechanism is by plastic flow by using Hertzian indentation theory, while material removal for brittle is by crack formation using Vickers hardness indentation theory. The constraints on the approach that need to be adopted is the use of numerical software and their coding, and also the manual calculation and derivation of all equations that will be involved. Another background study is this mathematical model can predict the axial cutting force and can be used with a variety of parameters under same material and conditions. The use of ultrasonic machining proved to be the best option to manufacture hard and brittle materials. Ultrasonic machining improves more on part quality, flexibility, and productivity compared to conventional machining. This type of ultrasonic machining could be sustained towards the economy and environment rather than the use of conventional machining in this current industry. For the problem statement of this project, machining these materials remains a difficult and challenging task for some manufacturers due to their distinctive characteristics. For example, high strength, high hardness, brittleness, chemical stability, and low fracture toughness. Other problems is this is only several papers are concerned with the modeling of various output response, even though numerous experimental research papers have been described the characteristics of ultrasonic assisted milling. So for the objectives of this study is to develop the mathematical model of cutting force for ductile and brittle mechanism of glass. The other objective is to analyze the influence of input variables towards machine surface finish and cutting quality. And lastly, to compare the predicted and model axial cutting force of ductile and brittle models with the experimental results of ultrasonic assisted milling of glass. For the scope of project, this project is hybrid, which is the combination of software and experiment. The models studied are ductile and brittle models. The software used is MATLAB, and the analysis used is mechanistic mathematical model. For the significance of this study, the mathematical modeling can predict cutting force without performing actual experiments. This project also guarantees that the quality of surface finish and machinability by using ultrasonic assisted milling could be improved when machining brittle materials, especially glass. And now we proceed to the methodology of this project. For the flow of this project, we start with literature review, then we do the model development and derivation, which is also mentioned as objective 1. Then we select the input variables of ultrasonic assisted milling, which is feed rate, depth of cut, and also spindle speed. Then we do the mathematical model analysis. It is also mentioned as objective 2. Now for the objective 3, we compare the predicted axial cutting force of ductile and brittle models with experimental results in ultrasonic assisted milling of glass. Lastly, we do the thesis and technical report. And now we proceed to the procedure for developing cutting force of ductile and brittle models, which is also the model development and derivation. So we start with the relationship between single grain force and grain indentation depth. Next, we need to identify the relationship between cutting force and single grain force. Then we estimate the actual volume of material removed by single grain indentation. Then we calculate the material removed volume from relationship between input variables and material removal rate, which is also known as MRR. Then we obtain the cutting force and compare with the experimental cutting force. For the preliminary results of this ductile model, we have obtained the indentation depth for ductile models, which is also known as polynomial. Next, we need to substitute the indentation depth or the delta into the final equation of axial cutting force for ductile models. Same goes to brittle models. We have obtained the equation for the indentation depth for ductile brittle. Then we need to substitute the values that we have gained into the final equation of the brittle model. Next, we need to identify the axial cutting force versus the input variables, which is spindle speed, feed rate, and depth of cut. We need to gain the value, but due to current problems on the MATLAB and the codings, I cannot get the result for this table. For the conclusion of this project, ultrasonic machining improves part quality, flexibility, and productivity compared to conventional machining. It is also does not produce thermal and chemical abnormal surface, so it is safe for our environment. It is also require lesser time to machine, and the machining operation is also economical. For the future works that need to be done during FYP2, we need to plot the graph and find the value of predicted and model axial cutting force on MATLAB software. We also need to compare the trend of the predicted result from the developed ductile and brittle models with experimental results by using MATLAB software. We need to identify the relationship between tool feed rate and axial cutting force at various cutting depth for both mathematical models with experimental results. We also need to analyze the relationship between cutting depth and axial cutting force at different feed rates and identify the relationship between volumetric removal rates, which is also known as VRR, and transitional axial cutting force. Then we need to do the thesis writing and technical report for the submission purpose. Now for the project planning or the Gantt chart for the semester 7, which is also for FYP1, we search for potential supervisor during week 1. Then we do some briefing for possible title and study project objectives until week 3. Then we understand the fundamental of the project and do the literature review and find the research paper until week 8. Then we do the model development and derivation of the equation until week 11. Then we could obtain the expected or preliminary result until week 13. Then we do the proposal writing, logbook, and pre-recorded presentation for the submission purpose during week 14. Then for the FYP2, which is also for the semester 8, we do the mathematical modeling and result analysis from week 1 until week 10. Then we do the thesis and technical report writing from week 6 to week 12. Then we do the final presentation and thesis report submission on the week 14 for the next semester. Alright, that's all for my presentation of FYP1 proposal entitled Ultrasonic Assisted Milling of Glass Development of Cutting Force Through Mechanistic Mathematical Model. Thank you so much for having a time to watch my presentation. If you have any inquiries, do contact me at the phone number and the email provided on the slide. I have submitted the logbook, the proposal, and the tentative proposal on the UFuture. You can check and evaluate from there. Thank you so much and have a good day.